Hello, pre-algebra students. This is Chapter 6.1, Ratios and Rates. A ratio uses division to compare two quantities. You can write a ratio of two quantities, A and B, where B is not equal to 0, in three different ways. You can write A to B. You can write A colon B, which is read A to B, or you can write A over B. Each ratio is read the ratio of A to B. You should always write a ratio in simplest form, as we're going to show in our first example on the next screen. An archer shoots 60 arrows at a target, with 44 of the arrows hitting the scoring area and 16 missing the scoring area. How could we evaluate the archer's performance? We could compare the archer's number of hits to the archer's number of misses by using a ratio. So let's begin by writing a ratio of the number of hits to the number of misses. First, we would write the number of hits, 44. Then we would write the colon, and we put the number of misses. So this would be read 44 hits to 16 misses. It could also be written like this, 44 to 16. We aren't quite finished with these ratios yet. We need to now write them in simplest form. We're going to simplify these just as we would simplify any fraction. First, we're going to look for the greatest common factor, and then reduce each side by that greatest common factor. So what would be the greatest common factor of 44 and 16? I'm going to go with 4. So we're going to divide each of these by 4 to get our new ratio, which would be 11 to 4. 11 and 4 don't share a common factor other than 1, so this is our simplest form. We could do the same thing in fraction form. We would simply write it in this way, 11 over 4 or 11 to 4. Now let's go on to assess the number of hits to the number of shots. The number of hits is 44 out of 60 shots. So our ratio is 44 to 60, or 44 to 60. Once again, we need to reduce. I'm thinking that our greatest common factor is once again going to be 4. So let's divide each by 4, giving us 11 to 15. Once again, 11 is prime, so we cannot reduce this any further. This is our simplest form. And we would write it like this in the fraction form, 11 over 15. And then the third way to write this ratio would simply be 11 to 15. However, you won't see that as often. They're typically written in this form or in the fraction form. Now, on your own, write the ratio of misses to shots. Make sure you put it in simplest form. Press pause while you work, and when you come back, we'll move on to the next idea. When we want to compare ratios, we can write both ratios as fractions or as decimals. Two ratios are called equivalent ratios when they have the same value. Let's look at a sample problem to explore this idea. The ratio comparing the length of a bird's wings to the average width of the bird's wings is the bird's aspect ratio. We're going to order the birds on this table from the greatest aspect ratio to the least. So the first thing we need to do is write each ratio as a fraction. So let's begin with our white-tailed eagle, where we're going to write the ratio of wing length to wing width is 209 to 30. We'll then divide our numerator by our denominator to get a decimal quantity, which is approximately equal to 6.97. Next, let's go on to the European jay. The aspect ratio will be 47 to 12, which is roughly equal to 3.92. Finally, let's find our aspect ratio for our black-headed gull, which is going to be 83 to 8, which is approximately equal to 10.38. Now we finish up this problem by ordering our aspect ratios from greatest to least. So the greatest is 10.38 for our black-headed gull, followed by 6.97 for our white-tailed eagle, and finally our smallest aspect ratio is 3.92 for the European jay. And there's our answer to that sample problem. You'll notice as we've been working with ratios that we're comparing two numbers that are in the same units. Now we're going to move on to rates. A rate is a ratio of two quantities that are measured in different units. So a unit rate is a rate that has a denominator of 1 when expressed in fraction form. Unit rates are usually expressed using the word per or for every. Let's work through a sample problem that shows that idea. So you're hosting a party for 12 people. The food and drinks for the party cost you $66. What is the cost per person? In other words, how much did you spend on food for each individual person at the party? Okay, so the first thing we want to do is write a rate comparing the total cost of the party to the number of people at the party. And then we need to rewrite the rate so the denominator is 1. That'll give us the unit rate. Okay, so first step, there are $66 spent for 12 people at the party, right? We want to find out what we spent per person. We need to divide 66 by 12. However, we also need our denominator to be 1. So we're actually going to divide both our numerator and our denominator by 12. Now we have 1 in our denominator, and we'll divide 66 by 12, which gives us $5.50. So the cost of food and drinks is $5.50 per person. That would be our unit rate. Now let's explore writing equivalent rates. A jet flies at 540 miles per hour. Write its rate in miles per minute. Okay, so to convert from miles per hour to miles per minute, we need to multiply the rate by a conversion factor. We know that there are 60 minutes per hour. So 1 hour over 60 minutes equals 1, right? So here's what we need to do. We're going to take our 540 miles per hour, okay? See how we set that up as a fraction? Per 1 hour. And we're going to multiply that by the conversion factor, which is 1 hour over 60 minutes. Okay? Now we can divide out common factors in units. So the hours will actually cancel one another, as will the ones. Okay? We can divide 540 by 60, leaving us with 1 here. And when we cross multiply, that gives us 9. Okay? So what do we have left? We have 9 miles per minute. Okay? And there it is. The jet travels at a rate of 9 miles per minute. Okay, that's a little tricky, so let's do another example like this. All right, let's work through this next example. A car travels at 60 miles per hour. What is the rate in feet per second? Okay, so we need to find two different conversion factors here. One is to move from hours to seconds. The other is to go from miles to feet. Okay, let's tackle these one at a time. So let's start with 60 miles per hour, and let's change that to seconds. What do we know? Well, first, we know that there are 60 minutes in an hour. So first, let's multiply 1 hour over 60 minutes to get to minutes. Okay? How many seconds are in a minute? That's right. In 1 minute, there are 60 seconds. Right? Okay. So this is now going to give us an answer in miles per second. And what will that be? It'll be, cross this out, cross multiply this. We keep our miles, our hours cancel, our minutes cancel. We're left with 1/60th miles per second. Okay, now we want to convert those miles into feet. So we begin by writing what we have here, 1 mile over 60 seconds. Okay, and now we want to convert miles to feet. What's the conversion factor for miles to feet? It is 5,280 feet in every mile. Don't worry, you don't have to memorize that number. We'll have a chart of conversion factors available for you while you're working. Okay, so now we're going to be in the units that we want, correct? We're going to have seconds on the bottom, and we're going to have feet in our numerator. Perfect. So now all we have to do is cross divide by 60, which is going to give us an answer of 88 feet per second. Right. So the rate that the car travels in feet per second is 88 feet per second. Okay, let's work one more. This example works a little differently, but I know you're going to get it. An insect crawls at a rate of 1 foot every 10 seconds. At this rate, how far will the insect crawl in 5 minutes? Okay, so we're going to work this exactly the same way we've always worked these problems. We're just going to insert our 5 minutes. So we begin with 1 foot every 10 seconds. Okay, we want to get our rate per minute, correct? So we need to know how many seconds per minute. There's 60, right? And then our final step will be to multiply by 5, because we want to know how far the insect goes in 5 minutes. Now we multiply this all out, cross-reducing where we need to. So here we can cross-reduce. Our seconds are eliminated. We can cross-divide here by 10, giving us 1 and 6. We can also eliminate our minutes here, leaving us with 1 foot times 6 times 5, which gives us an answer of 30 feet. So the insect crawls 30 feet in 5 minutes. All right, let's go on to our next idea. Here's another example that's very similar to the problem we just completed with the crawling insect. This, again, requires us to use equivalent rates to calculate a distance. So a robot travels 1 inch every 3 seconds. How far will it move in 4 minutes? So the first thing we do is express the robot's rate in inches per minute, which is 1 inch every 3 seconds. Okay. We need to convert that to minutes, right? Because we want to know how far the robot moves in minutes. So our conversion factor will be 60 seconds in 1 minute, which then we can cross-reduce, dividing each by 3, giving us 1 and 20. The seconds cancel out, giving us an answer of 20 inches per minute. Now, to calculate how far the robot moves in 4 minutes, we simply multiply 4 minutes times 20 inches per minute. The minutes will cancel one another out. We multiply 4 by 20 inches to get 80 inches. So in 4 minutes, the robot will travel 80 inches. What if we wanted to know the number of feet that the robot traveled in 4 minutes? Well, we just multiply by another conversion factor. We begin with our rate, 80 inches. We're going to multiply that by a conversion factor for inches to feet. In every 1 foot, there are 12 inches. Okay. Remember, we always set these up so that we can cancel out our units. Inches cancel inches. So this is the way we need to set up this fraction. It'll be 1 foot over 12 inches. Then we cross-reduce. Both 80 and 12 are divisible by 4, giving us a fraction that is 20 feet over 3. Now we want to change that improper fraction into a mixed number, which would be 6 2/3 feet. So if we were asked to give our answer in feet, it would be 6 2/3 feet. Okay, I'm going to give you some sample problems to try on your own, and that's going to close out chapter 6.1. Okay, try these 3 problems on your own. What is the equivalent ratio for 5 centimeters in 1 minute? How many centimeters would that be in an hour? Remember, there are 60 minutes in 1 hour, so you'll use that to set up your conversion factor. In problem 2, we want to find the equivalent ratio for 5 meters per second. How many meters per hour? Again, remember there are 60 times 60 seconds per hour, or 3,600 seconds in every hour. Finally, we have 3 pounds for $1. So how many ounces for $1? This one you probably don't know. There are 16 ounces in 1 pound. So you can use that information to create your conversion factor. Remember, when you're writing your conversion factor, think about writing it so that the units will cancel. You're trying to get rid of the units you don't want so you can end up with the units you do want. So for example, in number 2, when you're changing from minutes to hours, think about writing your conversion factor so that the minutes will cancel. So you're going to want your minutes in your numerator and your hours in your denominator, because you want your answer to end up with hours in the denominator. See how that works? Okay. Don't worry if you get stuck. We'll go over these together tomorrow. We'll also look more closely at more unit rates and writing conversion factors. See you then.